those who didn't attempt, don't worry, you cannot run away from calculus. All right, so the definition of our derivative from first principle is f prime of x is equal to the limit. Please take note, it's not f of x, it's f prime of x. If you put f of x here, you are now saying that the gradient is a function, yet it's not a function. Okay? So don't forget to put the prime. If f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay? Now, since this function is a little bit more complex, it is better to find f of x plus h first. Okay? Separately. So I'm going to do that in red. So f of x plus h will be equal to, all I have to do is just substitute where there is x here, I'll put x plus h. Okay? Where there is x here, yes, we replace that x by x plus h. It's function notation. Remember, you were introduced to function notation in grade 10. Okay, you need to pay attention. I gave you an opportunity to do the question at home last night. So x plus h minus 2. Okay? That's our f of x plus h. So I'm going to substitute this fraction where there is f of x plus h there. Where there is f of x here, I'll substitute the original function. Then I'll simplify. Are you following that? Yeah, it's not complicated. Alright? So, the next phase. So I'll say f prime of x will be equal to the limit as h tends to 0 of this. So that would be, sorry, minus 3 divided by x plus h minus 2 minus. Now, our f of x, it's minus 3 over x minus 2. So it's always better to put that in brackets. Okay, so I'll put in brackets here minus 3 over x minus 2. Right, this is all over h. Okay, now from here, the rest is algebra. It's not calculus at all, your knowledge of algebra. Right? So this becomes the limit as h tends to 0 of minus 3 plus, now that becomes minus 3 plus 3 over x minus 2, and here it will be x plus h minus 2, like that. Okay? So this is all under h. So we need to find the LCD of our numerator, because our numerator is a sum of two fractions. Okay? Please, you can't add minus 3 and plus 3 and then you say you've got a 0. You can't, because the denominator is not the what? The same. So the LCD here, it would be better to consider the LCD as the product of these two. Okay? So that will become limit as h tends to 0 of, then you multiply this denominator by that numerator, get minus 3 times x minus 2, then this denominator by that numerator that will be plus 3 times x plus h minus 2. This will be all over the sum of the two, that will be x plus h minus 2 times x minus 2. Right, allow me to convert this division line to a division sign. So I'll say h over 1. Right? So I'm going to simplify the numerator. Okay, please remember, you're not supposed to play with your phone in class. Don't forget that. Some of you are prefects here. You've got positions of responsibility in the school. Okay, so you must lead by example. Okay, so from here, we'll get, if I remove brackets, I'll get minus 3x plus 6. So this will be minus 3x plus 6, right, plus 3x plus 3h plus 3x plus 3h minus 6. This is all over the denominator, that one there. Well, this denominator, I write it as x plus h minus 2 times x minus 2, right? Then I'm going to say times 1 over h. Okay? Now, I'm sure you can see that some of the terms will cancel out. This positive 6 and that minus 6 will cancel. The minus 3x and the positive 3x will also cancel out. Well, just as a matter of advice, you cannot, or rather, it's not necessary to use FOIL in the denominator to remove brackets. It's not necessary. Okay? It's not. Right? So we're left with 3h in the numerator. I hope you can see that. It's all algebra. So this will be 3h over x plus, oh, that is what I'm supposed to write limit there. Sorry, limit as h tends to 0. Please don't forget to write that. What we haven't found the derivative yet. Okay, I put it there. I'm taking this out so that I can write the correct notation. Right? I have to write limit as h tends to 0 because I haven't substituted h equal to 0 as yet. Right? So you get 3h over x plus h minus 2 times x minus 2 times 1 over h. And then this h and that h cancel out. Okay? So our new gradient will be limit as h tends to 0 of 3 over x plus h minus 2 times x minus 2. Then, now I'm going to substitute h equal to 0. Okay? So it means that this will become 3 divided by x plus 0 minus 2 times x minus 2. So my final answer is going to be 3. Can you please drop this? The final answer, I'm going to write it in red. Whatever color that is. Okay, that should be 3 divided by x minus 2 all squared. Okay, if you want, we can simplify this and write the final answer as 3 divided by x squared minus 4x plus 2 plus 4. Okay, I saw this answer when I was checking some of your work. So this should be plus 4. Okay, all right. I hope you are following. So this question here, this is probably the most challenging you can ever get at this level in grade 12 in terms of finding the derivative from first principles for a hyperbola. Okay, yesterday I asked you to do these questions here, right? These are also challenging ones when it comes to first principles of a quadratic function and a cubic function. Yes. Yeah, the first one, the answer is 4x plus 3. The second one, the answer is 3x squared plus 4x. The last one is minus 9x squared. Okay. Right. Okay, is there anyone who has any question with regard to first principles? Because I'm concluding it now, and you have to know this for your calculus. Okay? For your June exam, the first question on calculus will be on first principles, and it's usually 5 marks. Okay? Like, if you don't have any questions, just allow me to do a question on application of first principles, the gradient of a tangent at a point, and function notation. Okay, so I'm just going to go over this question here as an example, just to reinforce everything I've said over the past few days up to today. Right, so So this is more like an application question which you may get. Okay. So the question says, consider the function f of x equal to minus 2ax squared plus 2x. So this is our function. It's a quadratic function. Okay? So when you see the equation of a function, you should know what type of a function it is. So that's quadratic. Since it's quadratic, it means the derivative of it is going to be a linear function. Right? So the first question says, determine